So welcome everybody from wherever in the world that you are. I think we have people in India, in Europe, Italy, in West Coast, East Coast, New York, Atlanta, all around the world. Obviously a very crazy time, different time for a lot of people. So I thought it was important to, one, give you guys context about what Librium Research Institute is about, and talk a little bit about how the impact of agent-based modeling we do at our company, and how it is very similar to the virus. So a little bit about myself, JP James. I've been a passionate educator and entrepreneur for decades. And Jody has been helping lead a lot of the efforts with Librium Research Institute, which is really focused on our ability to utilize pragmatically the science of agent-based modeling. And for those of you who aren't familiar, we'll be going through a little brief understanding of what agent-based modeling, how it is in the marketplace, how you can apply it, and how we've applied it. One of the companies that I helped start is a consumer lender, and it is really focused on the impact of compounding and being able to understand things like friction in market and how to utilize compounding to make an impact. So that's a little bit about the Research Institute. And Will, while you're not speaking, could you mute yourself? I think it's giving a little bit of feedback. But we'll get started here. All right, so a few points that we're going to go through. One is just for you guys to get a high-level understanding of what interest is as a function of a loan, understanding compounding. Some key questions for you to think about through the presentation, really understanding what the science is that we're talking about with fractal math and its integration within agent-based modeling. What are understanding how constraints of system impact compounding effects, how to optimize a system, and how to understand the difference between a top-down statistical modeling approach versus an agent-based model. You can also call it agent-based simulation. And how you can actually take this forward, what are some of the gaps in the science that we've seen, and how we can work together to get your help on understanding this. Okay, I'm going to start with a video, which is a little bit complex technologically to figure this out, so I apologize in advance if it doesn't work.
Einstein is reputed to have said that compound interest is the eighth wonder of the world or something like that. And it goes back to that story you probably learned when you were in grade school where somebody did something for the king and the king said, "What can I do for you?" And he said, "Well, let's take a chessboard and put one kernel of wheat on the first square and then double it on the second and double it on the third." And the king readily agreed to it. And by the time he figured out what 2 to the 64th amounted to, he was giving away the entire kingdom. So it's a pretty simple concept, but over time, it accomplishes extraordinary things.
It was a little complicated process to try to get you to understand compounding, which I know it sounds obvious, everything that Warren was saying in the video. I can definitely tell you, and from Will, who leads finance at High Financial Systems, and a lot of the people on the team, compounding sounds really simple and the effect sounds really simple, but the math behind it is very, very complex, and that's why we're going to go through that a little bit here. Okay, so one of the first things, and I'm going to talk about it from the context of High Financial Systems, which is a technology company that manages consumer lenders. So obviously as a consumer lender, you have customers or borrowers, and you have to understand the different attributes that those customers have to be able to figure out the influence of things like default rate, if they're going to pay, how much do they want, how much should we lend, in both directions from that component. So obviously, once we've decided that a person or customer is approved to get a loan, then there's obviously this back and forth of cash that's going to be going, one from the lender to the borrower, and then obviously through time. So the biggest problem is, how do you track the movement of that dollar? And how do you optimize the function of speed of delivery, both outbound to the customer and inbound back from the customer, and how quickly can you turn that over? Now, even just thinking about this presentation right now, this sounds like the simplest, obvious, most problem that you could possibly imagine. But we're going to show here in a real quick second, and Will, you can unmute yourself, of what happens to a dollar. So obviously, if you lend out a dollar and there's interest rate, when that money comes back in, those payments come over a period of time. So as it comes over a period of time, you then can take that cash that's come back in and re-lend it out. And what ends up happening is a compounding effect. Now, you have to account for what's called slippage. For those of you who've been in the hedge fund space, there are trading costs, there are inefficiencies of time. In the lending space, it's how much does it cost to acquire the customer? What are the different services like payment processing, like call center reps, different expenses that are required to actually run the business? What's the default to the customers, and any other management costs that are related to that? So let's just do a theoretical 50% interest rate for a single dollar that we're going to lend out, or a single amount of money that we're going to lend out. Well, what we do, we'll take an example of a lending portfolio that lends out the money and expects to get all that money back in 32 weeks. So it's 16 payments within that time frame, and which is a payment every other week. So this is approximately an 8-month loan. So you're getting 1/16 of the cash per payment that's coming in. Now, theoretically, on a single dollar that you've lent, a single unit dollar that you've lent out, within that time frame, you should get about $1.31. So everybody should be following so far, fairly straightforward. Now, Will, I'd like you to kind of explain, what does this mean?
Sure. And I guess to kind of take a step back, conceptually, a dollar being kind of worth more in a system versus on a unit basis is a pretty common phenomenon, especially in modern economics, when stimulus and other things like that are discussed. Essentially, the policymakers have an understanding that $1 injected into the economy from the government in specific places actually have a multiplicative effect on GDP. So if you allocate $100 towards building a road, the actual impact towards GDP is actually closer to $1.40. If you think about the supply chain it stimulates, the workers' wages, what they do with those wages once they get home, it kind of makes a lot of intuitive sense, but something that we took the time to do is really model out what what that would look like for a lending business or any sort of income or investing type of business generally. The two obvious things that are very important are, A, are you actually receiving positive, unit economics? B, what is the velocity that is associated with each dollar that you are investing or deploying? So for us, within 2 weeks, roughly for this sample loan, we'd be expecting to have in hand within 2 weeks 1/7 of a new loan. So, if you think about just how many different units are in play from that starting bucket of capital, say that this starts out with, $100 in, $100 worth of loans, then you have roughly, call it $13 to $14 at the end of 2 weeks. You're still expected to receive, call it $90 from the initial loan, and you have $13 in cash on hand that you can then lend out that also has its own return profile, meaning that instead of receiving 1/7 of a new loan in that second payment, the total time-scaled value of that is much greater than just that 1.7. The speed to collection and deployment allows a kind of simple unit, within this example being worth, over 32 weeks at 50% interest, rather than it being, a 30% return on invested capital. The true value over, 12 weeks in time could be anywhere between, 100 to 175%, because each subunit, this kind of one, not one, is its own kind of fractal set. If you think about kind of in nature and fractal mathematics, the Mandelbrot set is essentially something that continues to show similar structure and shape as it is delved into and fleshed out. And I mean, it's the very exact same concept here in terms of, taking capital and making it infinitely more productive.
Cool. And we've got some more fun slides that we'll be referencing in a minute.